So what we have here is a simple sketch. A simple sketch. Now I'm going to ask you some questions. There are no trick questions in this part. All right. So, and if anyone wants to shout out some answers, then it will make my life easier, and I won't look so silly because I've just asked questions. Okay. So here's a sketch. It's got no constraints. Now the one thing about that is that now if Paul moves one of these curves, like the end curve, that happens. Okay. So it all breaks apart. So think about what you have to do today, no matter which version you're using, and which software you're using. For those of you not using NX, you'll have the exact same challenge. This is a challenge around sketching. So how do we solve it? Oh, come on, guys, this is coming. Please help. Add constraints. So we can add constraints, and we add tools like like auto-constraining. So what Paul's now doing is he's going to auto-constrain this. So now when he moves the curve, let's see what happens. So if you pick up a curve now, Paul, and just move it. Well, he's moving that line. Everything stays connected. Yep, everything stays connected. Yeah. Thank you. All right, so here's the question. What's happened to the big radius? The radius there? It changed size. I'll give you the answer. Okay? How do you stop it from changing size?
Constraint.
You add more constraints. You fix it, you add dimensions, you add more information. So that was the problem. And yes, we gave you auto dimension, but that's the problem, is that you have to give lots of information. So we thought, hang on, if we apply synchronous to this, can we solve the problem? So what Paul's just done is he's gone backwards, you're going back, and he's taken out all the constraints. He just did a couple of undos. The system tells you it needs 233 constraints to solve this problem. And using a command now in NX9, synchronous in 2D, what Paul can now do is just do move curve, and in this case it's found also the symmetry, and he moves that over, it stays connected. If he moves the top line, he's got symmetry. Notice the arc stays the same size, it remembers the tangency. We'll take the other line, and you see he's adjusted the angle, tangent is updated. No constraints on this sketch whatsoever. Okay, so here's an interesting one. And this one, I promise you, is not a trick question. If we pick the arc at the end and delete it, what happens? It disappears, right? Thank you. Do you know, I did this at a user conference in Scandinavia, and actually nobody answered. And then when I deleted it, everyone went, oh yeah, of course. And I say, well, I did say there's no trick question. So sure enough, but if you use synchronous to delete this, what's going to happen? Well, if you use synchronous to delete this, the system rejoins the curves, trims it all up, and you get a good boundary. Now, this is especially useful if you've used that profile to extrude it or revolve it, and then then that way you get updates that all work. Now, we're going to move on a little bit. Other uses for synchronous. Ever had a situation where somebody has given you a DXF file, and you have to make a couple of changes to it?